Today we are going to make a voltage-controlled amplifier based around an analog device's AD633 using a Reckless Experimentation Audio Proto 1 Eurorack breadboard module. Parts list and circuit schematic is in the description below. First, let's look at the circuit schematic and see what's going on. The core of this circuit is the AD633 analog math chip. It single-handedly does the entire VCA on its own. While not a cheap chip, it's simpler to use than matched transistor pairs in traditional VCA designs. The LM833 serves only to boost the level of the envelope generator. If you're using an envelope generator with a 10-volt max output, this circuit would be more appropriate. The schematic and parts lists are in the description below. For the purposes of today's circuit, we're going to assume you're using an envelope generator with a 5-volt output. The control voltage from your envelope generator comes in here. The 100K potentiometer acts as a volume knob and can be omitted if not desired. The control voltage passes through an inverting amplifier with a gain of 2. This will take the 5-volt envelope and still produce unity gain across the amplifier. This connects to the X2 input on the AD633, so it does not invert the signal. The signal to be amplified is directly connected to the Y1 input. The transfer function of the AD633 is here. As you can see, many more things are possible with this chip. The output of the chip is connected to the output jack. The unused op-amp is set to ground. Now let's look at how we build this circuit on the breadboard module. Step 1. Remove the 3 screws and separate the front plate to gain easier access to the breadboard. 2. Place a 10 microfarad capacitor near the top of the board, noting the polarity. Negative rail is on the left side of the board, positive rail on the right. Ground is available on both sides. Then place the chips on the board. The dot on the chip denotes pin 1 and should be on the left side. Leave some room between the chips for easier wiring. Next, add the power and ground connections. The op-amp has positive to pin 8 and negative to pin 4. The AD633 is a little more complex as both the positive and negative power connections are on the right side of the chip. An extra jump to the bus below the chip keeps things neat. Now wire the ground connections for both chips. Now place a jumper between the output and the negative input on the unused op-amp. Add a jumper from the output of the left op-amp to pin 2 on the AD633. Now the final 2 parts on the breadboard are a 20K resistor from the output to the negative input and a 10K resistor to the negative input to ground. Now we can bring the front plate back in. I recommend labeling the connections with masking tape. Start by attaching the bottom red wire of the potentiometer to an open bus, the middle red wire to pin 3 on the op-amp, and the black wire to ground. Attach the top jack to the same bus, the bottom red wire of the potentiometer, and the black wire to ground. Attach the red wire of the second jack to pin 3 and the red wire third jack to pin 7 of the AD633. Attach the black wire of these jacks to ground. Now reattach the front plate with the 3 screws. Connect unused jacks to an empty bus and fold the wires flat. Now attach the power cables. Red stripe on the cable to the red paint on the breadboard. Initial testing with a current limiting power supply is recommended. Once satisfied with initial testing, mount to your enclosure and we can see what it can do. Connect up the inputs and outputs. Today we are using a Doffer A-143-9 for our signal source, a Blue Lantern Simple ADSR2 for our envelope generator, a Q nexus for the gate signal, and CV for the A-143. Now let's hear what it does. Here are a few scope traces.